Hey mathematicians, we are getting ready for the next two congruence theorems. We just learned SSS, side, side, side last time, right before the Thanksgiving break. And we're going to learn two new ones today. So let's go ahead, jump right into it so we don't waste any of your time, and we'll see how this goes. So the two that we're going to be dealing with today are called side angle side and hypotenuse leg. So side angle side is weird because it's not just about sides and angles and sides and having one angle and two sides marked. It's very specifically about having a triangle where the two sides that are marked are the ones that make the angle. The two sides that are marked make the angle. We call that angle the included angle. So we're basically looking for triangles that have, I guess I should have had two, that have a situation like this, where we got side, angle, side marked just like that. It can be any kind of triangle, as long as you got side, angle, side marked. Side, angle, side. Can look like a lot of things. So we can go very obtuse, side, angle, side. And we need to try to clarify some of this early, because one of the big misconceptions is, where are we getting this from? Where is this all coming from? And so if I've got a triangle and I've got stuff marked, we are going around the edges of the triangle. So we have, if we went, it doesn't matter which way you go, but if we went this way, we would have side, side, angle, which, if you spell it backwards, is not great. But because again, it doesn't matter which way we go, when we're going around the edge, consecutively we have a side, an angle, and a side. Right there, this shape is what we're looking for. That's all we need. So let's ask ourselves, can the following triangles be marked congruent by saying side, angle, side? And this is actually the hardest they're going to get, because there's something special going on here. This goes back to two chapters ago. We got parallel lines here, right? So remember, when we have two parallel lines, let me use the eraser real quick. When we've got parallel lines and we have a transversal that connects them, then the alternate interior angles are congruent. So I've got alternate interior angles that are congruent, and then on top of that, this shared side is congruent. So I've got that shape that I'm looking for, that side, angle, side shape for markings. And again, if I shared this side, side, angle, side. So I'm going to say yes. I can say BC, according to these markings, side BC is congruent to side, let's see, B to C, so D to A. Okay. I can say that AC is congruent to itself. And I can say angle DAC is congruent to angle BCA. Those are the ones that I marked as alternate interior. Alternate interior. So, knowing that I've got the side, the angle, and the side, I can say triangle ABC is congruent to triangle. Okay, so I went from A to B to C. So this one I need to go from C to D to A. Triangle CDA. Because we have to make sure that everything matches up every time. You gotta make sure all the letters match up. Everything's got to match up appropriately. So we know angle B and angle D are the same, and we can see that. everything should match up if we use the letters right. So that's the worst they get. That's the worst. The question we have now is, can these triangles be marked congruent by SAS? And so we're going to add in the side we know, right? We know this side's there. But if I'm following around one of these triangles, let's look at triangle ABD, this triangle, the top one. If I'm following around, I've got A around the side, S, and you can see what's happening here. That is not side angle side, because if it was side angle side, for this side, this angle would have to be marked, and it's not. So, no, not enough information to make side angle side work. Yes, we have two sides and an angle, but not in the right order around the edges of the triangle. So on your homework assignment, those are the ones we've been putting NEI in the blank for not enough information. Hypotenuse leg is different. Hypotenuse leg, okay, for a side to be a hypotenuse, the angle has to be a right angle. And so we need the hypotenuse to be marked and one of the legs to be marked. So if we had two triangles and we had the hypotenuse marked and one leg marked on both of them, and we knew this was 90 degrees, because that's the key, right? Has to be 90 degrees for that to be a hypotenuse. Then we have everything we need. So let's look at these ones. Are these two congruent by HL? Well, 90 degrees, that's our first step. Yep, got 90 degrees on both. The hypotenuse, based on those markings, side AB is congruent to side DE. And then, again, based on the markings, the leg, side AC, is congruent to side DF. So, if you see 90-degree angles in these triangles, you should check HL. Doesn't mean it's always going to be HL, but you should check HL. Because that's the situation that all these, that when there's 90 degree, I'm going to pause for a second. Because when there is a 90-degree angle, that's probably what they're asking for. They're asking you to check the hypotenuse and the leg. And then if not, maybe it's something else. Let's check the next one. Are these congruent by HL? Well, personally, I'm going to rewrite these. When they're all pushed together like that, so we're checking WYZ and we're checking XZY. So if I do WYZ, and then I'm going to flip the other one. We're allowed to do that, so that they look the same, right? I mean, that's the whole point. So the X was up top, the Z was down bottom. No, excuse me, the Y was down bottom. And then the Z was over here. We already know that ZY equals itself, right? We also know WY equals XZ. So I've got things that are useful, but there's some things I don't know for sure. So I have used this, already used that, put the markings on. I don't need to put markings on. I mean, I need to put markings on, but I didn't need to be given that. We know that's the same. Then they tell us, okay, WZ and ZY are perpendicular. So WZY, that's a right angle. They also tell, so we've used that. They also tell me XY and ZY are perpendicular. So that's a right angle. So now that I know they're right angles, I know I can check hypotenuse leg. If I know WY, which again was given to us, is congruent to XZ, and I know that ZY is congruent to YZ, then I have the hypotenuses marked, I have the legs marked, and that means we can say the triangles are congruent. triangle WYZ, just like it says, is congruent to triangle XZY. If you're watching this video and you're really confused, I really want to encourage you to come to the Google Meets. This particular unit is not easy to learn from a video. And if you're sitting there and saying, yeah, it is easy to learn, well, then that's not for you. But please, I've got 3 people come to the Google Meets regularly, and I would love for you to join them. I'm going to explain this concept tomorrow. So finally, we don't get told which one we're going to use. We're just being asked, are the 2 triangles congruent? And if so, explain which theorem makes them congruent. So the first thing I'm going to do is I'm going to say, okay, all right, if WXY is a straight line, then this is also a right angle. And the way they've said this, YXZ, so Y to X to Z, is congruent to WXZ. And so if you are me, we can tell that mark needs to be here, and it's not. So these are not congruent because, well, I should say, not enough information, because we could find out that this is the same. We just don't know. So there's not enough information. We cannot say that they are congruent. I hope that you've got enough to go into this assignment. The assignment is, as always, retakeable. Please take it as many times as you need to. Message me if you get stuck. And if you can, come to the Google Meets so you can get whatever help you need. I hope you have a good day and a good last 3 weeks of the semester. I will see you in the next video.